Today we're going to talk about the three primary equations of motion, otherwise known as the kinematic equations. We've already encountered one of these when we were talking about the definition of acceleration. This equation is usually rewritten in a way that is more handy. The final velocity is equal to the acceleration times the time it was accelerating for, plus whatever initial velocity the object had. This is the first of the three kinematic equations. Notice that both the initial and final velocities, the acceleration and the time, are involved, but we do not know what distance is involved. If we want to know the distance traveled while accelerating, whether it's slowing down or speeding up, we have to use a new equation. The distance covered is our change in position vector. This is equal to the initial velocity times the time we're interested in, plus 1/2 the acceleration times the amount of time squared. Notice that our second kinematic equation looks like a quadratic equation. This means sometimes you have to use the quadratic formula to find the time. Let's do a couple examples with this equation. Say you're stopped at a stoplight. Since you're stopped, we know that your initial velocity is equal to 0 meters per second. After the light turns green, you accelerate at a rate of 3 meters per second squared, for a total of 2.5 seconds. The question is, how far did you travel during that 2.5 seconds? Since we want to find the distance, we'll use the second kinematic equation. So delta D is equal to 0.0 meters per second times 2.5 seconds plus 1/2 our acceleration of 3.0 meters per second squared times 2.5 seconds, all that squared. When we plug this into our calculator, we still have to round to the correct number of significant figures, and we find that the car traveled a total of 9.4 meters forward during that time. We could also ask, how fast are we going after 2.5 seconds? Well, since we know the initial velocity, the acceleration, and the time, let's use the first kinematic equation. So Vf is going to be equal to the acceleration of 3.0 meters per second squared times 2.5 seconds plus our initial velocity, which was 0 in this case, giving us a final velocity of 7.5 meters per second. Of course, there are occasions when we know the acceleration and the velocities, but don't have the time that the acceleration acted over. Fortunately, there's a third kinematic equation for just this situation. This equation takes the square of the final velocity and sets it equal to the square of the initial velocity plus 2 times the acceleration times the distance in which the acceleration occurred. Now we have a full set of kinematic equations. Let's do an example with the third one. You're traveling along at 22 meters per second, and you decide to slow down so you don't get a speeding ticket. Slowing down implies that your acceleration is opposite of your initial velocity, negative in this case. Perhaps your acceleration when you hit the brakes is equal to negative 2.8 meters per second squared. If you hit the brakes for a total of 43 meters, what is your final velocity? Notice that time has no part in this problem. We're going to use the third and final kinematic equation. So our final velocity squared is going to be equal to 22 meters per second squared plus 2 times negative 2.8 meters per second squared times 43 meters. If you plug it into your calculator, you'll find that you have 484 meters squared per second squared minus 240.8 meters squared per second squared, which is equal to 243.2 meters squared per second squared. Of course, to find VF, we have to take the square root of 243 15.2 meters squared per second squared, which gives us a 15.6 meters per second for our final speed. Notice how this is speed, not velocity. You have to use your reasoning to figure out what direction the car is traveling at the end. Is it possible that it turned around? Or is it still going forward? So that's going to depend on the setup. In this case, the car is still going forward, so we keep it as a positive 15.6 meters per second. Now that we have the three kinematic equations, there's many more situations that we can solve problems for. And I will show you in the next video how to choose which equation to solve which problem.